Yep, so we are back. Question number 9. Question number 9 is actually the last question on the series of practice questions we have been doing so far. Now, in this question here, we're actually given a different kind of function. This is an example of a spliced function, or you could call it a piecewise defined function. Now, the very first question here says, or let me read the function here so it makes more sense. It says f of x equals x squared when x is in the range of -2 to 2 with the endpoint inclusive. That is, only when x falls within this range, that is when you use this function value. But then it says whenever x is greater than 2, do not use this definition for the function, but instead use this definition. That is exactly what this definition actually implies. Now, the very first question here we have, it says find the domain of the function. Now, the domain of the function is actually the range of values of x for which the function itself is defined. So looking at this, we have two ranges here. The first range is this is the first range of values of x, and then the next range is actually what we have here. That is this. So now what we are told is that we are told to find the range of values of x for which the function is defined here. So maybe it's be very good if we try to draw our number line. So you recall your number line, assuming this is our number line. Now what we have here is, it says the function is defined from -2 to 2. So let's cross -2, and let's assume this is 2. And then is also defined for x greater than 2. So now how then do I represent this on a number line? So from -2 to 2. So I'm going to represent that with this sign here. So the function is defined for this. So between -2 and 2, the function is defined. But then it doesn't stop there. It says -2 is inclusive. Why? Because of the equality sign we have here. And it also says 2 is inclusive. Why? Because of the equality sign we have here. So since -2 is inclusive, I shade this part, and 2 is inclusive, I shade this part. So it doesn't stop there. This is for the first one. Now the second definition says it's also defined for, that is, the function is defined when x is greater than 2. So when x is greater than 2, that is just going to be what we have here. That is x greater than 2. That is greater than 2. So it is greater than 2. So all this like that on and on is greater. It's for all values of x greater than 2, the function is defined, and then when the function the domain lies within this range here is also defined. So we are told to find the domain of the function. The domain of the function is actually the union of everything here. So in other words, the domain is just going to be the set of all real numbers, such that now you can see it goes from -2 to 2 and from 2 to infinity. So it's just x greater than or equal to 2. That's your domain. Another way to write this is that is, since all the range of values of x, that is, since everything here is inclusive, you could also say -2 to, so since it goes to infinity, would write infinity, and then you write this sign here. Now -2 is inclusive, since this side is shaded here, so would write this here. So you should note, do not write -2 infinity. Write this and then write this. This is not allowed. It is customary to always write your infinity sign in this way, that is with the ordinary bracket sign and not the square bracket. So you should watch out for that. So let's go ahead. How then do you graph this kind of function? Now, funny enough, there are two functions here. This is the first function, and then this is the second function. Now, to graph this function, I'm going to have to draw two tables of values. So how then do I start? Now, for the first function, which is what we have here, it says f of x. So I'm going to assume I have two functions. F of x equals x squared, and then the range is from -2, less than or equal to x less than or equal to 2. So let me draw my table of values. So you have something like this, something like this. So if this is my x, this is going to be my f of x. So my range of values goes from -2 to 2. So you have -2 to 2. So let me just include any value between -2 and 2. So let's include 0. So when x equals -2, when we substitute it into here, we have -2 squared, which is 4. When x is 0, f of 0 is 0. When x is 2, f of 2, which is 2 squared, is 4. So if I want to graph this function here, which I'm going to do right now, is I could start by, let me label my x-axis. So this is 0 here. So let's assume this is 1. So let's say this is 2, this is 3, 4, and let's say this is 5. Let's assume this is -1, -2, -3. This is 0. This is let's say this is 1, or let me say 2, 4, 6, and then 8. Yeah, something like this. And then probably the middle is going to represent 4, 5, 6, and 1. So we have a graph, something like this. This is my y-axis, and then this is my x-axis. So this is what we have. So now let's graph this function here. So it says when x equals -2, f of x is 4. So when x is -2, f of x is 4. So that is somewhere here. So that's the first point. So when x is 0, f of x is 0. So when x is 0, f of x is 0. That's this point. Then when x is 2, f of x is 4. When x is 2, f of x is 4. This is f of x equals 4 here. So something like this. And then if you want to join this, so you could just join this, something like this. This is how the graph should look like, something like this. Now you would observe I did not extend this graph beyond this point. Why? Because I said the function is only defined from -2 to 2. So since the function is defined from -2 to 2, I'm going to have to tick in this part here, telling me stop here, do not go further. And then it stops at 2 here, telling me stop here, do not go further. So this is the full definition of the function. This is actually a curve. It's meant to be a very clean curve, but I believe you understand what I'm trying to do here. Now this is for the first definition. Now let's go to the next definition, which says f of x equals 2x -1 when x is greater than 2. So let's do that also. Now for f of x equals 2x -1, and then it says for x greater than 2. So let's go ahead and draw a table of value for that. So we could just choose, so it says x greater than 2, so let's go from 2, 3, 4. So when x is 2, if you substitute into here, 2 times 2 is 4, minus 1, that's 3. X is 3, you substitute here, 2 times 3, 6, minus 1, 5. X is 4, 2 times 4, 8, minus 1, that is 7. So when x is 2, so I'm going to have to plot these values here. So let's see, let's plot those values. So when x is 2, f of x is 3. So when x is 2, f of x is 3. This is 3 here, 3 is somewhere here. So let's assume the graph is somewhere around here. And it's somewhere around here. Then it says when x is 3, f of x is 5. When x is 3, f of x is 5. So somewhere around here. And then it says when x is 4, f of x is 7. So this is my 5, this is my 7. When x is 4, this is my 4, and then this is my 7. So here we go. Then there's something you need to observe here. It's here there is no equality sign here. So since there is no equality sign, I am not supposed to shade this part here. That is, 2 has been excluded from the graph of this function here under this definition here. So that's why I'm using an empty circle bracket. But assuming it had something like this, the equality sign, then that implies I have to shade it, simply implying that the 2 itself is inclusive. So because it's not inclusive, that's why I use an empty shade there. And then you join you join this. Let's say you have something like this. This is supposed to join anyway. So, but like, this is how the graph should look like. It's supposed to be a straight line anyway, but you should understand what I'm trying to do here. So now then, the bone of contention here is you begin to wonder, where does it stop? Now, since what it says here is x greater than 2, which simply implies x goes from 2 to infinity. So since it goes to infinity, I'd use an arrow here telling me it goes to infinity. So you can see right from here, it starts from 0 and then it goes to infinity. So that's why I use an arrow there. But assuming there is a bus stop, I would make a circle and then shade that part. You understand? I do hope you understand this part. So this is actually the graph of the function, a sketch of the graph of the function. All right, let's go ahead and answer the next question. Now the next question here says, based on the graph that we drew above, find the range of the function. Find the range of the function. Now let me give you a very neat definition of the range of a function. The range of a function is also known as the height of the function. And similarly, the domain of a function is also known as the width of the function. So we are told to find the range of the function. The range of the function is just the height of the function. So where is the lowest point on the graph? This is the lowest point here. So it goes from here, so somewhere here like this. So this is starting from here. So let me have a very good shade. So I'm starting from here, then it goes to, and if you see here, it goes to infinity. So this is like the height of the function here. So where this here goes to infinity, so you can see it starts from the point 0. So it starts from point 0 to infinity. That is exactly what we are seeing here. That's the height of the function, from 0 to infinity. So if you want to write the range of this function, we would say y goes from 0. Now since 0 is inclusive, we use this 0 to infinity. So this is going to be the height of the function. So the range equals, you could just say the set of all real numbers such that y is greater than 0, or you write, y greater than or equal to 0, or you write 0 to infinity. Yep. Now the next question here says, find the function value at -1. Now you recall the function we are given is f of x equals, we have x squared, and we said we use this whenever x falls within this range here, and then it says 2x -1 whenever x is greater than 2. So there are two things here, involved here. Now for the first one, you use this definition if x falls within this range, and then the next one says use this definition if x falls within this range here. Now what we're given here is we are told to find the function value at -1. Now looking at the two of them, -1 falls within this range because -1 is between -2 and 2. So since it falls within this range, it implies that I'm going to use this definition here. So for f of -1, you could say since -1 falls within the range -2 less than or equal to x -2, then f of -1 is just going to be -1 all squared, which is 1. But for the next question here, it says find f of 3. Now my 3 here doesn't fall in this range, but instead it falls within this range here because x greater than 2, that is 3 falls within this range here. So you could just say since 3 belongs to the range x greater than 2, so we would use this definition here. So my f of 3 is actually going to be 2 times 3 minus 1, so which is going to be 2 times 3 is 6 minus 1, and that is 5. So this is the solution here, and this is the solution here, and then that completes the whole problem. Thanks.